So now that we know how to create a buffer, now let's look at how a buffer actually works. Like, why does a buffer pH? Well, let's do the example of the acetic acid with its conjugate base. What would happen if I added an acid to this system at equilibrium? So what if I added a small amount of hydrochloric acid? Well, the immediate effect is that hydrochloric acid is going to dissociate into hydrogen ions and chloride ions, right? Or hydronium ions and chloride ions in water. The immediate effect is that you are going to increase the concentration of hydronium in your solution. So your pH would decrease, and a lot of biological systems do not work if you change the pH. So since this is a system at equilibrium, my buffer's response could be to shift the equilibrium left. If I can shift the equilibrium left, then I'm going to decrease the concentration of hydronium till my pH increases back to its original value. So as long as I don't overwhelm my buffer, so I can't add more acid than my buffer could buffer, but if I add just enough, then my system could reach equilibrium again. If I was to add a base, for example, something like sodium hydroxide, which completely dissociates into sodium and hydroxide ions, then the hydroxide ions that are added are going to combine with the hydroniums, right? These guys. And what's going to happen is that your hydronium ion concentration is going to immediately decrease, right? I'm increasing my pH. When you add hydroxide, it takes hydronium out of the system, and then you are becoming more basic. Your pH is increasing. Well, your equilibrium would shift to the right. If I decrease the concentration of hydronium, then my equilibrium shifts right to produce more. So then my hydronium concentration would go back up so that my pH can go back down, right, to its original value. Awesome. So that is how an acidic buffer is going to work. What about a basic buffer? What if I had something like ammonia and water in equilibrium with ammonium and hydroxide? How would this buffer solution react to the addition of magnesium hydroxide? Well, the easiest thing I like to do is kind of use the example that I've done above to help myself see the effect. If I'm going to add magnesium hydroxide, I'm going to be adding magnesium ions and hydroxide ions. So when I add magnesium hydroxide, the concentration of hydroxide ions would increase. When that happens, if I increase my concentration of hydroxide, then my pH is also going to increase, which is bad. We want our pH to stay the same. So what's my response going to be? Well, my equilibrium will shift which way? Now, because this is a basic buffer, I'm increasing the concentration of hydroxide, whereas if I added an acid, it would decrease the concentration of hydroxide. But I'm adding a base, so I'm increasing the concentration of hydroxide, so my equilibrium would shift left, which would cause my hydroxide ion concentration immediately to decrease, which is going to make my pH do what? I'm decreasing my concentration of hydroxide, right? So then my pH is going to decrease as well. And then that's going to be back to the original pH. So what does it all come down to? Le Chatelier. We love it. The other thing I want you to notice is that when we were making making our buffers, that we had ammonium chloride here because you can't add an ion, right? An ion can't be added to solution, so we're going to always add it as a salt, but really the only thing we needed was the conjugate acid-base pair. So ammonium chloride and ammonia is going to be our buffer solution. Okay, so that's the end of that one.